In the relentless pursuit of speed, we find ourselves cooling plastic much, much faster than we normally do. And that got me thinking. This X1 Carbon has an auxiliary fan. That's a good idea. A normal blower fan usually isn't enough by itself to cool down plastic fast enough when you're just printing fast. So what do you do about it? Well, you add more fans. How do you do that? Well, Fysetc believes they have the solution. Now this is my Ender 3, and a normal Ender 3 will not really get fast enough to where you need an auxiliary fan, but this Ender 3 gets that fast. I've been experimenting with Clipper, and yeah, speed is fun, but it must be tamed. And that's where Fysetc comes in. They've devised this kit right here that uses 4 40-20 blower fans to push air down through these channels and all across the entire x-axis. These comprise the components of our auxiliary fan. What you're going to get with the kit is 4 fans, this PCB, some heat set inserts, screws, and T-nuts. The housing you will have to print yourself. I recommend printing it in ABS because if you print in an enclosure or if you just print anything hot in general, you know, PLA tends to warp. So don't use PLA for these components. Use something like PETG or ABS at the very least. Now right away I do have a gripe with the design portion that holds the fans in. It holds fans in perfectly fine, like that, and you can route the wire as you need. But when it comes to the very furthest end one, we have a bit of a problem. You see, if I could get this in here, it doesn't leave any room for this wire to be routed. You need some space. So I'm going to file this away or Dremel it away a little bit to cut a little orifice for this to route through. The reason why that's a problem is because this component slots into this component and it's just flush with the back here, and if that wire, which it will, gets snagged by the back end of this, you're just going to destroy the wire. Now, I wouldn't necessarily recommend doing this with ABS because the fumes will definitely get you, but I just melted the plastic a wee bit with a soldering iron, and yeah, it seems to have done the trick. It's a little messy, but hey, we're after functional, not pretty. This is what the bank of fans looks like. Sucks in air from this side, blows it down, and then it blows out of these channels down here. However, problem number 2, these fans are splitting when they're placed inside, which causes them to be a little bit off kilter and creates a little bit of friction that I don't particularly like. But we're going to see how much of a problem that really is. Now, let me be clear about something. Fysetc does not include instructions for this kit, so I'm going to assemble it the best that I can figure out how. And that starts off with putting this adapter plate with the 3 holes upside, 2 holes on the downside, and this adapter bracket gets placed on the back of your x-axis gantry, like that. Now, you screw in from the opposite side that we're looking, and that goes into this. Now, these are heat set inserts. It comes with them, but you're going to need to set them in yourself. I just used my soldering iron to do it, and it seems like it did a pretty decent job. If my camera would focus, that would be nice, but point is, that's what we're going to do. So let's flip this machine around and screw it in. As you can see, the plate just mounts like this, and it allows you some flexibility. You can raise and lower this component depending on your hot end. This hot end used to be a Mark 8, but now it's a Revo system, and it comes down just a tiny bit lower than before. So having some adjustability is fantastic. One part of this design that I thought was quite clever is the fact that it didn't just design this for the Ender 3. It's actually going to work on most reasonably sized bed slingers. You can move this up and down to adjust to whatever height you need, which is perfect because, you know, standard Ender 3 runs a Mark 8. This isn't a Mark 8 anymore. This is a Revo, and it comes down a little further than your typical nozzle. So having some adjustability is good. Now that we've got it in place, I bet you're wondering, how do you power it up? Well, it comes with a power cord. Just plug it up there, but it doesn't come terminated on anything. So you can do this a few ways. You can plug this directly to a power source and babysit the printer by turning the switch on and off when you're doing something, but that seems a little ridiculous. What we're going to do is something completely different. We're going to terminate this with a JST connection, hook it up to the motherboard that controls everything, and we're going to cannibalize a port. We're going to use the port on here that's normally used for cooling the MCU, but we're going to use that because that one can adjust fan speed, and use that to power this. We're going to remap it in Clipper so that way it knows that this is an auxiliary fan, and then we're going to get a 5-volt fan because all the three 24-volt pins are being used. So we're going to use a 5-volt fan to hook up to the GPIO ports on the motherboard for the 5-volt and ground, and that way the motherboard will always have a permanently on powered fan to cool it off. So just for reference, I'm using a big Fysetc SKR Mini E3 V3, and this is currently my wiring setup. As I stated before, there's only three 24-volt pins for fans. That's here, here, and here. So what we're going to do is take the GPIO port over here. One of them is a ground, one of them is a 5-volt, and we're going to wire in a 5-volt fan so that we still have something to cool this motherboard off with. So some of them work, some of them don't. So you can kind of hear the fans rattling around in there. You know, ABS is the right material to use for this job, but it does shrink a tiny bit. And I'm thinking I'm going to have to reprint this in a slightly bigger scale, because if I do too much, these fans get stuck, and then I have to manually restart them, which is not good. They'll get hot if it gets stuck. And then when I slot this in here, it presses up against everything, make it squish, and that is causing the fan to get stuck. So, let's reprint this slightly bigger and see if that solves our issue. It would appear that after adjusting for ABS shrinkage, the fans fit a lot better. Even this area where the wire needs to be tucked away can go in now. I used 98% as my ratio, so meaning if it's supposed to be 100 millimeters and you measured 98, well, then you would put 98. Now that I've reprinted it, adjusting for that ABS shrinkage, the fans are spinning beautifully now. And they are pumping a good amount of air. So to give you guys a little bit of demonstration as to how much air we're moving here, we will drop this paper towel, or toilet paper. Yeah, I'd say that's pretty good. Alright, so I don't know who needs to know this, but if you have a big Fysetc SKR Mini E3 V3, you have three 24-volt ports for power modulated fans, kind of like this. But this is not a 24-volt. You see, I've used all three of those ports. So what I've done is I've taken a 5-volt fan and wired it in to the 5-volt and ground SPI outputs or inputs, whatever you want to call it, on the motherboard. And that allows this to be a permanently on fan that I can use to cool the motherboard, and I can take those PWM controlled ports and use them for other things like auxiliary fans. This is the print going right now. Yeah, you're going to notice that there's a few things different on the hot ends. I swapped out the ABL for a different style ABL, and I reprinted the shroud to get rid of the mount for that ABL. So, that's the only thing that's really changed. This is going pretty well, I would say. Those overhangs on the bow of the boat are usually pretty bad. So we'll see what we can do when this thing is done. So you may be seeing me right now, I'm crying a little bit, and that's because my eyes are extremely dry. This thing behind me moves a lot of air, and when I'm sitting in front of it, it dries out my eyes. So it's not one of those things where you can just kind of sit down and watch it print. It's actively fighting you now. Well, the print is just about to finish. 29 minutes on a benchy. 8 of those minutes were preheating and scanning. So, 30-minute benchy, subtract 8 minutes, so 22-minute benchy, approximately. That's not bad. Let's take a look at our results. Alright, that should be a little bit better. This thing came out relatively decent. Now, here's the thing. I'm still working on getting the slicer to play nice with the fan. I told the slicer I have an auxiliary fan, but it didn't kick on. So I had to go into Clipper and tell it to manually turn on. And you can see right about where that happened. Because right where that happened, the quality suddenly got really good. So part of my issue here is that I have some under extrusion because I'm going pretty fast. Unfortunately, I don't currently have a high flow Revo nozzle, so I'm waiting for that to come in the mail so I can do some further testing, but I'll tell you what, I'm pretty impressed. Benchies are fun and all, but they don't really tell us what I'm really after, which is what exactly is the quantifiable improvement between using this auxiliary fan and not using one at all. So let's do some overhang tests. So just for reference, I'm not going to do speed benchy speeds for overhang tests because I actually exceed my maximum flow rate of my nozzle right now. So we're going to slow it down to what you would actually reasonably print at. I basically told the speed to go back to default while maximizing the cooling on the parts cooling fan portion. We're going to do a test with and without the auxiliary fan. So this is the overhang test. The left is without the auxiliary fan, and on the right is with the auxiliary fan. Now, at first glance, you might think there's not much of a difference. And that's because I slowed down for overhangs in the slicer. Look at the blobbingness. From 70 to 80% overhangs. That is a lot flatter and a lot more solid on the right than it is on the left. You can see those droops right here on the most extreme portion of this overhang. There is definitely an improvement. So I completed a bit of a torture test via bridging, and over on the left we have the print without the auxiliary fan, and over on the right we have the print with the auxiliary fan. And there's some very interesting things to note. First off, let's talk about the bridges. How far can we go? Apparently, not very far, because 5mm bridge got a little droopiness about it, and then we start to get more and more droopiness, especially when we get to 30mm. But let's take a look over here. Our droopiness isn't quite the same, and that's what I want to talk about. Let's switch it over to the rear, where it gets to the most extreme of 100 millimeters. Look at the bridge over here on the left, the stock versus the bridge on the right. The bridge on the right is technically better, but it's also blown to one side. This auxiliary fan really blows a ton of air, and if you don't use it wisely, you could push a bridge line in a different direction from the wind just gusting at it in a horizontal direction. So, that's kind of weird. Didn't expect that exactly, but let's also talk about one last thing. The top of the bridge, because that's where we see the biggest difference. The bridges up top, you can see, are losing their infill. Oh, hold on, manual focus. You can see they're losing their infill. But the one on the right, it's a solid line up top all the way through. If you were to print on top of this, you would have a solid surface to print on. If you were to print on top of this, you'd be printing on essentially under-extruded bridge. If you made it this far into the video, chances are you were just as curious as I was to see if this little upgrade was worth your time, effort, and money. I am happy to report that I think it is. That being said, here on this channel, we don't review 3D printers. I review 3D printer components. That's more interesting to me, because when you have a printer, you got to make it your own. So, if you want to see more videos like this, get subscribed. I do shorts of my progress, and then I do community posts of various things like discounts that I can find from my viewers from big companies or announcements in the industry I can quickly post about. So it's a lot of 3D printer stuff on this channel. So hopefully I will see you guys in the next video. So remember, measure twice, print once.